Hello everyone, welcome to another IB Physics video. Today we have a paper 2 question related to chapter 2, mechanics. And let's get right into it. Here, this question comes from the 2018 November paper 2 test. I'll give you some time where you can pause the video and read the question. You can then pause at any time and continue watching the video. Alright, so this question relates to a spacecraft that uses ions as a way to propel itself through space. The question A asks you to determine the initial acceleration of the spacecraft. So first of all, we have to get two equations. First, the Newton's law, force equals mass times acceleration. Second, the force is also equal to the impulse divided by the time. Getting the impulse is a relatively easy task. The only thing you have to find is a change in mass and multiply by the change in velocity. The change of mass over time is what we call the rate of change of mass. And this is given by the problem as 6.6 times 10 to the negative 6 kilograms per second. The information is highlighted in blue in the problem. Next, we have to get the change in velocity. And we know the change in velocity is just to find the velocity of the ions because the ions start or ejected from rest. We multiply these two and we can get the force. To get the acceleration, we divide by the mass according to this equation. And some simple calculations with the calculator will show that this is 4.6 times meters per second squared. Moving on to the next question. Question B. I asks you to estimate the speed of the spacecraft. And there's two methods to do this. First of all, if you know how fast the fuel is being burned and how much fuel you have to burn, you can get the time that you spend accelerating. So this would equal to the fuel mass divided by the rate of fuel usage. The fuel mass is of course 30 kilograms as highlighted in blue. It's half of the 60 kilograms because you can only use half the fuel to accelerate. Next, you spend the fuel at 6.6 times 10 to the negative 6 kilograms per second. Dividing this gives you 4.6 times 10 to the 6 seconds, which is the time you can spend accelerating. We already found the acceleration in the previous problem, so we can use that to find the change in velocity. And here you can see that the change in velocity will be 2.1 times 10 to the 10 to the third meters per second. There's another option, and the second option is, well, we know that all this fuel is ejected as ions at a certain velocity, so the change in momentum of these ions will equal to the change in momentum of the spaceship. Of course, there's 30 kilograms, like we pointed out before. The velocity of the ions will be 5.2 times 10 to the 4th meters per second. And it has to equal to the 710 kilograms times the velocity of the ship. And we used 710 kilograms because we subtracted 30 kilograms that we will use to propel the spaceship. Next, we can just calculate this and we get a slightly different answer, which is 2.2 times 10 to the 3rd meters per second. Next question asks us to outline why the answer to BI is an estimate. And there's several reasons to this. The first one is that the acceleration is not constant. And this is because the mass of the ship keeps getting reduced not every time, as the fuel is used. Second thing you can also say is that external forces such as gravity and such may act in the ship, making the acceleration non-uniform. Either one of this is correct. You can make your own other answer, but since this is only 1 point, you only need one answer to get the full points. Next question, it says, outline why scientists sometimes use estimates in making calculations. And this is more a subjective question, so it doesn't matter what you write. As long as you write one of the correct answers, you will be fine. So just write as much as you can. Here, one of the possible answers is that the problem may be too complicated and requires simplification to be able to be solved. Another possible answer is that it makes the calculations and equations simpler. Another answer may be that some values are not known exactly, and because some of the values are already estimates, so it doesn't really change much if you estimate the whole answer. And lastly, it's in cases where precision is not important, where you just want a rough estimate of what you need, then you use this type of estimations. Part C1, it says outline why the ions are likely to spread out. And you can see here that 1, the ions have the same charge. 2, well, if they have the same charge, they have to repel. So you always have to have a reason and a conclusion. So the reason is that the ions have the same charge, and the conclusion to that is that because they have the same charge, they repel. Going on to the next question. This question asks you to explain what effect, if any, the spreading of the ions has on the spacecraft. And this is a trick question because, first of all, the forces between the ions does not include the spacecraft. So if you apply the forces, there's a force on one ion and a force on the other ion. So these forces do not include the spacecraft in any way. Therefore, there is no effect on the acceleration of the spacecraft. All right, that's it for today. Thank you for watching this video. I'll see you next time.